Okay, so we continue with exercise 3E on page 80 of the UPM. First question, or the next question, number 5, you have a point A. So A is somewhere here. And you have a point B somewhere here. The coordinates of A are A, 3, and the coordinates of B are 2 and -3. So there's a line joining these 2 points, right? Then now what we're told is that there's another point C, and the line joining C to B, this is perpendicular to AB. So the coordinates of C are 10 and 1. So now we want to find out what is the value of this point here, A. Right, now to work that out, first we'll work out the gradient of BC. This, as you know, is delta y over delta x. So we just take the difference in the y value, so 1 minus -3 over 10 minus 2. So that you can do on your calculator, like I've done there, and the answer is 1/2. Okay, now what we know is AB and BC are perpendicular, so it means that they're product of their gradient. So when I multiply the gradient of AB with the gradient of BC, this is equal to -1. Okay, so then I can make the gradient of AB the subject of the formula. This is -1 over the gradient of BC. So this is -1 divided by 1/2, which is equal to -2. Okay, then I find the gradient of AB using the points and the formula. So the gradient of AB, this is -3 minus 3 over 2 minus A, and this is equal to -2. So here we can cross multiply, and the numerator will have -6, and then -2 multiplied by 2 minus A. Then divide both sides by -2. This gives us 3 is equal to 2 minus A. Okay, then this -A will come this side and become +A, and then this 3 will go to the other side, and we have 2 minus 3, which is -1. So that is our value of A. Okay, next question, number 6. Number 6, we are given the points A, which is 0, 3, B, which is 4, 7, and C, which is 10, 5. We are told that they form a triangle. There is our triangle. That's A, B, and C. And L is the midpoint of AB. So AB, the midpoint is L. And M is the midpoint of BC. So M is over here. Then show that LM is parallel to AC. Okay, so if we were to draw this line here, we must show that this is parallel to AC. And remember what it means for lines to be parallel. It means that their gradients must be equal. So it's enough just to work out the 2 gradients and then show that they're the same. That means the 2 lines are in fact parallel. Okay, so we need to work out L and M. So L, because it's the midpoint, we use the midpoint formula. So I say 0 plus 4 divided by 2, comma, 3 plus 7 divided by 2. This is 2, and this is 5. So this is the coordinate of L. It's 2, 5. Then I do the same thing with M. The coordinates of M, it's the midpoint of BC, so that's 4 plus 10 divided by 2, then 7 plus 5 divided by 2. Okay, so these two. 4 plus 10, 7 plus 5, both divided by 2. So this is 14 divided by 2, which is 7. And this is 12 divided by 2, which is 6. Okay, so this point here is 7,6. All right, now what we want to show is that the gradient of AC is equal to the gradient of LM. So we look for the gradient of AC. This, as we know, delta Y over delta X. So A and C, so we say 5 minus 3 over 10 minus 0. Okay, so this is 2 over 10, which is 1 over 5. And then we do the same thing, the gradient of LM. This, again, delta Y over delta X. This is 6 minus 5 over 7 minus 2. Okay, this is 1, this is 5, so we have 1 over 5. Then you say something like, since the gradient of AC is equal to the gradient of LM, then AC is parallel to LM. Okay, and that is how you answer that question. Okay, the next one is number 7. We have a triangle with vertices. Let me just copy this, take it down here. Okay, so we're doing number 7 now. So we have a triangle with vertices DEF. So let's draw a triangle. Let's see, D is 0, 2. E is 8, 6. And F is 2F. Now we are told that the triangle is right angled at D. So in my sketch, I should have read everything before I sketched it. So if there's a right angle at D here, so it'll look slightly different. Let me just redraw it. It'll look something like this. This is D, E, and F, because the right angle is at D. The coordinates of D are 0, 2. Of E, this is 8, 6. And F, this is 2F. Using gradients, find the value of F. So basically all we need to do is find the gradient of DE, multiply that with the gradient of DF, and this should be equal to -1, because here we have a right angle, and a right angle means they are perpendicular. So we can already use the formulas here. We know the formula of the gradient is a 6 minus 2 over 8 minus 0 multiplied by 2 minus F over 0 minus 2. So it's 2 minus F, 0 minus 2, and this is equal to -1. So this one here we can work out. 6 minus 2 over 8 minus 0. This is a half. 2 minus F over -2. This is equal to -1. So this gives us 2 minus F over -4 is equal to -1. 2 minus F is equal to 4. And then the minus F can go to this side, become positive F, and the 4 can go to this side with 2 minus 4. This means that F is -2. Okay, so that one is pretty simple and straightforward. Question 7. Then question 8. We have the points A, B, and C form a triangle. And then this time the triangle is right angled at C. So we have something like this. The right angle is at C. Our coordinates are 0. Sorry, that's A. So our coordinates are A is 0, 2, B is 8, 0, and C is 5, C. Then the question says, by finding expressions for the gradients of AC and BC, find the possible values of C. Okay, so we want the gradients of AC. So we say C minus 2 over 5 minus 0. This is just C minus 2, 5. And then BC, the gradient of BC. I should write that a little bit. The gradient of BC, this is 0 minus C, we'll make it minus 0 over 5 minus 8. This is just C over 5 minus 8. Now we know that AC is perpendicular to BC because the right angle is at C. So that means the product of these two should be equal to minus 1. So we say that the gradient of AC times the gradient of BC is minus 1. So we have C minus 2 over 5 times C over 5 minus 8. This is equal to minus 1. And this equation is the one that we are going to solve. Okay, so we know how to multiply numerator times numerator, denominator times denominator. So C times C, this is C squared. And then minus 2 times C is minus 2C. Then in the denominator, 5 times 5, this is 25, but I didn't even to do that. It's much easier if I work this out. 5 minus 8 is minus 3, and then just say 5 times minus 3, which is minus 15. Or you could do it the other way, where you say 25 minus 40, you should still get minus 15. Okay, and this is equal to minus 1, and now we multiply by minus 15 on both sides, so we have C squared minus 2C is equal to positive 15. This means C squared minus 2C plus 15, not plus 15, minus 15. This is equal to 0. So this is a quadratic equation, and we know how to solve quadratic equations. Either you factorize, you complete the square, or you use the formula. So if we were to complete the, not complete the square, factorize, would look for two numbers that when you multiply them, the answer is negative 15. And when you add them, the answer is negative 2. So that is negative 5 and positive 3. So when we factorize, we have C minus 5 and C plus 3. This is 0. So C minus 5 is 0, or C plus 3 is 0. This means C is 5, or C is minus 3. So those are the two possible values of C. Okay, then the next question Number 9. We have points A, B, C, and D. They form a quadrilateral. So we can sketch that. I shouldn't draw it like a rectangle because I don't know that it is a rectangle, but it's some quadrilateral. This is A, B, C, and D. A is 3, 4. B is 5, 0. C is -1, -3, and D is -3 and 1. Now the first question says find the gradients of all the lines A, B, B, C, C, D, and DA. So the gradient of AB, this is 4 minus 0 over 3 minus 5. This is minus 2. Yeah. And the gradient of BC, this is -3 minus 0 over -1 minus 5. Three minus 0, which is just 3. Gradient of CD, this is -3 minus 1 over -1 minus -3. And then we want the gradient of AD or DA. This is 4 minus 1 over 3 minus. Okay, that is the first part of the question. Then the second part said find the lengths of the lines AB and AD. So we want AB. Okay, so this line, this is the square root of 3 minus 5 squared plus 4 minus 0 squared. Okay, this is 2 squared. Okay, and then we want AD. Excuse me. Okay, AD, this is 4, 4, 3. 3 minus -3, we square this, plus 4 minus 1. Calculator. Okay, now the last part says, hence state what type of quadrilateral it is. Okay, so first we're looking at these gradients. We see that the opposite sides, AB and DC, they have the same gradients. So opposite sides, AB and AD, these are parallel. And then these ones, AD and this one, those are also parallel because their gradients are the same. And this is a 90-degree angle because the product of those two is equal to -1. So you have 90-degree angles throughout. This side, A, B, C, D, this is 2 square root of 5, and this side is 3 square root of 5. So they are definitely not the same in length. So that means that this is a rectangle. So A, B, C, D is a rectangle. Okay, so it's important to look at all of this. What does it mean when opposite sides are parallel? Is it just one pair? Then it would be a trapezium, but its opposite sides are parallel. So the A, B, and C, D are parallel. A, D, and B, C are also parallel. So the two candidates for that are a parallel, not two, the three candidates would be a parallelogram, rectangle, or a square. Okay, for a square, the all the sides must be equal, but these two are not equal. So that narrows it down to rectangle. But keep in mind that a rectangle and a square both are parallelograms. They're just special types of parallelograms. Okay. The next thing we look at is the equation of a straight line. There are three ways that we can come up with the equation of the straight line. We know that in standard form, an equation has the form, a straight line has the form y is equal to mx plus c. Okay, that is in standard form. So the first way that you can come up with the equation of the line is if you are given the gradient m and a point like this, 0c, the y-intercept, then you can just write the equation of the straight line exactly like this. So where you have m, you replace it with the value that you were given, and where you have c, you replace it with the coordinate of the y-intercept. Okay, then the second way we can find the equation of the straight line is if you are given the gradient and a point on the line. Okay, this is called the 1-point gradient formula. And the way to do it is you write y minus y1 is equal to mx minus x1. So your x1 and y1, you substitute the numbers that you have from your point and then the gradient, and then you can make y the subject of the formula so that the equation is in standard form. Then the third way is if you are given 2 points on the line. So you're given x1, y1, and x2, y2, right? So the formula for our line will say y minus y1. This is y2 minus y1 over x2 minus x1 multiplied by x minus x1. So this is the formula that you can use if you are just given 2 points. And this, you will see, is the equation of the gradient. So if you have 2 points, you can work out the gradient and then basically just use the 1 point gradient formula. You get the exact same thing. Okay, now let's look at some of the questions in exercise 3F. Okay, question 1. A says find the gradients of the following straight lines. So this equation y is equal to 3x plus 2. It's already in standard form. So all you need to do is look at the number in front of the x, or the coefficient of x. So here our gradient is equal to 3. So if your equation is not in standard form, the first thing you must do is write it in standard form, and whatever the coefficient of x is, that is your gradient. Then C, we have y is equal to minus 3x plus 1. Again, this is in standard form. The number in front of the x is minus 3, so this means my gradient is minus 3. Then E, y is minus 2 over 3x plus 3, again in standard form, so the coefficient of x is my gradient, so m is minus 2 over 3. Then G, y is 5 plus 2x. So you can write it in standard form. It technically is, because y is the subject of the formula. This is 2x plus 5. So the 2x does not become negative because it's still on the right-hand side of the equation. So the coefficient is 2. That means 2. I have y minus 2x is equal to 4. We need to write it in standard form. Y is equal to 2x plus 4. This is the coefficient, so m is equal to 2. K, 2y plus 8x plus 5 is equal to 0. So y must be alone, so we start by saying 2y equal to minus 8x minus 5. And then we divide everything by 2. Y is equal to negative 4x minus 5 over 2. So the coefficient of x, that is our gradient. Okay. M, 3x plus y is equal to 4. So this 3x should go to the other side, so it's in standard form. So if minus 3x plus 4, this is our gradient. And O, we have x over 4 minus 2y over 3 is equal to 1. So this y should go to the other side so that it becomes positive. This 1 should go this side. So we have x over 4 minus 1. This is 2 over 3y. Then I can always rewrite this as 2 over 3y is equal to x over 4 minus 1. So nothing has gone over to the other side. So it's the same thing like when we say x. If 5 is equal to x, then it means x is equal to 5. X didn't go over to the other side. All right, then we multiply everything by 3. So 2y, this is 3x over 4 minus 3. Divide everything by 2. So y is equal to 3x over 8 minus 3 over 2. So this number here in front of the x, that is our gradient. Right, then question 2, find where the following straight lines cut the y-axis. So the y-axis is your value of c in the equation y is equal to mx plus c. So first, make sure it is in standard form, and then the number, the constant, that is your c, that is where it cuts the y-axis. So for a, y is equal to 2x plus 3. It's in standard form, so this means that c is equal to 3. Then b, we have y minus 3x is equal to 4. This is not in standard form, so we have to write this in standard form. So doing that, we have y is equal to 3x plus 4. So this is our c. 2y is equal to 3x minus 8. We need to divide by 2 so that it's in standard form. So y is equal to 3 over 2x minus 4. So that means my c is minus 4. And d, 3x plus 4y minus 12 is equal to 0. We need to write this in standard form. So we say 4y is equal to minus 3x 12. And then we divide everything by 4. Y is equal to minus 3 over 4x plus 3. This is C. If x over 3 plus y over 2 is equal to 1. So first we have y over 2. This is minus x over 3 plus 1. Multiply everything by 2. So y is equal to minus 2 over x plus 2. This is our constant term, so C is 2. Okay, question 4. We have the line y is equal to x minus 2. We have to find where it cuts the x-axis, where it cuts the y-axis, and then sketch the line. So if we work out where it cuts the x-axis and where it cuts the y-axis, to sketch the line, we just need to connect those 2 points. So where it cuts the x-axis, A. So it cuts the x-axis when y is equal to 0. Okay, so here we'll substitute y is equal to 0 and solve for x. So we have 0 is equal to x minus 2. This means x is equal to 2. So it cuts the x-axis at 2, 0. And then B says where it cuts the y-axis. So that means we're looking for C, the y-intercept. So to get the y-intercept, our equation just needs to be in standard form, which it is. And this minus 2 is the y-intercept. So C is equal to minus 2. So at the point 0, minus 2. That is where it cuts the y-axis. And now a sketch, you just draw the x and your y-axis. So this is x, and that is y. So the point 2, 0 is somewhere here, and then 0 minus 2 is somewhere here. Connect them with a straight line. And then y is equal to x plus 2. This is 2, and this is minus 2. Okay, make sure your y-axis is also labeled. So that is how you would solve question 4. Question 5, you would do it in pretty much the same way, nothing different. Then question 6. Question 6, we're given the line y is equal to 2x plus 4. And then this is a multiple choice question. We are asked which of the following lines are parallel to y is equal to 2x plus 4. So remember, for parallel lines, the gradients must be equal. Okay, so we need to check each of the options from A to D, which of them has a gradient that is the same as our line. So first of all, we need to know what is our gradient. Our gradient, because it's in standard form, we can see that the gradient is 2. So we're looking for lines with a gradient of 2. So A, y is equal to 2x minus 1. M is 2 because it's in standard form, therefore is parallel. So A is parallel, yes. Then we do the same thing with B. So B, we have 2y is equal to x plus 3. If we write this in standard form, we have y is equal to x over 2 plus 3, 2. The gradient is a half, not parallel. Okay, then C, we have 3y minus 6x is equal to 1. So when you write this in standard form, we have 3y is equal to 6x plus 1 divided by 3. Y is equal to 2x plus 1 over 3. The gradient here is 2, and therefore is parallel. Okay, so C is parallel. So this one we say not parallel, this one is parallel. Then we do the same thing for D, 2x plus 3y. So D is the line 2x plus 3y is equal to 4. In standard form, 3y is equal to minus 2x plus 4 divided by 3. So y is equal to negative 2 over 3 plus, this is an x, plus 4 over 3. The gradient here is minus 2 over 3, and that means it is not. Okay, so only A and C are parallel to the line that we are given. Okay, with number 7, we are given the line y is equal to 2x plus 4. And with the 4 options, we have to check which of them is perpendicular to our line. So here our gradient is 2 because it's in standard already. So we need to look for a gradient that is equal to negative half. So this is what we're looking for in the lines that we'll have to check. Because when I multiply these two gradients, those are the ones that give us a product of negative 1. So option A, we have y is equal to a half x minus 4. Here the gradient is a half. We're looking for minus a half, so A is not parallel. Then is not perpendicular rather. Then B, y is equal to minus a half x plus 7. M is negative a half because it's already in standard form. So this one is perpendicular to our line. C, we have 2y is equal to 5 minus x. In standard form, y is equal to negative x over 2 or half x plus 5 over 2. The gradient here is negative a half. That is what we're looking for. So C is also perpendicular to our line. And then D, we have 2y is equal to x plus 5 divided by 2. So y is equal to a half x plus 5 over 2. Here the gradient is positive a half, but we're looking for a gradient of negative a half. So this one is not perpendicular. So this D is not perpendicular. Number 8, the line y is equal to ax plus b is parallel to 2x minus 6. So we have a line y is equal to ax plus b. We're told it's parallel to the line y is equal to 2x minus 3. Remember what parallel means. Parallel means the gradients are equal. That's number 8. Gradients are equal, okay? And then we are told it passes through the point -1 and 7. So that means -1 and 7 satisfies the equation. So we start with this here. Because they're parallel, the gradient here is 2. It's in standard form. So this means the gradient here, which is a, is also equal to 2. So the solving for a is easy. A is equal to 2 since m1 must be equal to m2. All right, and now our equation becomes y is equal to 2x plus b. And we know it passes through the point -1 and 7. So when we substitute the x and y coordinates, the equation must be satisfied, and we can we can work out the value of b. So here, if it passes through the point -1 and 7, so this will be my x, that is my y. So I have 7 is equal to 2 times -1 plus b. 7 is equal to -2 plus b. That means b is equal to 9. Okay, so we have found the values of a and p, and we can write the equation is y is equal to 2x plus 9. Okay, and then number 9, we have the line y is equal to cx plus d, and we're told it's perpendicular to the line y plus 2x is equal to 4, and cuts the line, so it cuts y plus x plus 3 is equal to 0 on the y-axis. Now we have to find the value of C and D. So we start with this fact that it is perpendicular to this line. So we'd work out the gradient of this line here, and then the negative reciprocal of that gradient, that is the value of C. So we have y plus 2x is equal to 4. So y is equal to -2x plus 4. Our gradient here, m1, is -2. So our m2 or c, so c is -1 divided by -2, which is a half. So that when I multiply these two, my answer is equal to -1. So far our line now becomes y is equal to a half x plus d. Okay, now we are told that it cuts the line y is equal to, y plus x plus 3 is equal to 0 on the y-axis. So what that means is it passes through the same y-intercept as the line y plus x plus 3 is equal to 0. Okay, so try and picture this. I have one I have my x and y axis, this. So I have one line here, and then it says it cuts this line. Let's say this was our line x plus y plus 3 is 0. I'm not saying that's what it is, but let's say that's what it is. Then our other line goes something like that. So it meets this line on the y-axis. It means the y-intercept of this line is the same as the y-intercept of that line. So it shares a y-intercept with y plus x plus 3 is equal to 0. So we need to work out what is the y-intercept of this line, and then that will be the value of d. So to get the y-intercept, we write it in standard form. Y is equal to x plus 3. So this is our y-intercept. So d is equal to minus 3. Okay, so we've worked out our values. C is a half, and d is minus 3.